Hello, wanted to put together a video to go over significant figures. I sometimes call them sig figs. Some people call them significant digits or sig digs. In this case, it doesn't matter what you call them. You just need to make sure you understand how they work. So I have put together, since I've been teaching, what I consider to be 3 rules. The original set of rules is actually it comes out to like 6 different rules, and I would rather limit it down to 3, which I think cover absolutely everything. One of them is a little multi-stepped, but I think this is easy to go. So this is the best way that I've been able to explain it, and so let's just get to it. There are 3 rules for significant figures, okay? Rule number 1, okay? Any number that is not a 0, aka 1, 2, 3, 4, 5, 6, 7, 8, 9, is always significant at all times. It's a given. Okay, so any number that is not a 0, but in this case, any number that is an actual digit, not 0, is always significant. Always. Okay, there's no exceptions. Okay, it's always those. So for instance, if we look at the number 589, so if we're looking at this number right here, when I look at that, I see all numbers that are not 0. Therefore, there are 3 significant figures to that number. Pretty straightforward. Okay, so most people get rule 1 pretty quick. Like, that one's pretty straightforward. Rule number 2, any number, and I put 0 in here because it's the only one that hasn't been covered yet. Any number, in this case 0, that is between 2 significant numbers is therefore significant. Okay, and what that means is, and it makes sense, like for instance, if we had a number, let's say, let me see here, if we had a number like 101, and we know that the hundreds place is going to be significant, and we know that the ones place is going to be significant. Well, what does that tell us? This number in the middle must be significant, because if I add 9 to the ones place, I'm going to end up with 110. Okay? Meaning that this is a placeholder that is holding the position of the tens place. And since we know hundreds is significant and the ones is significant, this placeholder in between therefore must be significant. Because if we couldn't trust this number, there would be no difference between 101, 151, you know what I mean? Like 191. This placeholder must be significant. So don't worry about the whole understanding the place thing. All you need to know is this. Any number in between 2 significant figures must be significant. So let's take a look over at this one right here, okay? So 18,005. And again, I didn't put a comma there just for simplicity case. I mean, a comma doesn't affect anything. When we look at this, we can see right here that the 1 is significant. We can see the 8 is significant, and we can see the 5 is significant using rule number 1. And you always start with rule 1. Once you've clarified that 1, 8, and 5 are significant, we then can look to see if there are any other numbers that are between significant figures that have not been counted. Well, we see that there are 2 zeros here. Well, let's see if we can count this. This 0 has a significant figure to the left. It also has a significant figure, not immediately, but to its right. Okay, so it's not immediate, but it's still got one to its right. So it's got one on its left, one on its right. Since they're both significant, this 0 must be significant. Same thing here with this 0. Maybe not immediately, but it's got a significant figure to its left. It's got a significant figure to its right. Therefore, this is significant. Okay, so with rule 1 and rule 2, we get 18,005 has 1, 2, 3, 4, 5 significant figures. Okay? Now, let's go and take a look at using rule 1 and rule 2 at another number. Okay? We've got 101,010. Okay, like I said, no comma. If you want, I'll put the comma in here. Perfect. Okay. We start off with rule 1. 1 is significant. 1 is significant. 1 is significant. Okay, so we've got 3 significant numbers. Go to rule 2, any number between 2 significant numbers. This 0 has a 1 and a 1, so therefore it's significant. This 0 has a 1 and a 1, Therefore, it's significant. And again, remember, it doesn't have to be 1. It could be any number, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's get to this zero. Well, this one's got a significant number on its left, but it doesn't have anything on its right. So therefore, this is not significant. Okay? So in this case, this is 5 significant figures, significant digits. Okay? Now this leads me to Rule 3. Rule 3 is a 2-step rule to an extent, but to be honest, Rule 1 is pretty easy. It's any number that's not 0. So I still consider it to be just one rule, right? Rule 1 is like a half a rule, right? Rule 3 is like 1.5. Here we go. Rule 3, you have to do Rule 1 and Rule 2 first. So let's do it. Let's look here at 7.00600. Okay? First rule, any number that's not 0. Okay? 7 is not 0. 6 is not 0. Okay, so that's Rule 1. Rule 2, any numbers between significant digits. Well, this 0 is between. This 0 is between. These, well, there's nothing over there. I mean, there's a 0, but that's not significant, so we can't count that. So we only have 7006. Now let's go to Rule 3. Rule 3, after that we check for a decimal place. Is there a decimal? Yes, there is. So if you find a decimal, start from the far left, just like you're reading a book. We always start, I'm sorry, my video is probably flipped here when I look at that. Anyway, look over to the far left-hand side, just like you're reading in a book, and start from that side and move across, okay? So here we go. I'm going to pretend there's things over here. Nothing, 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 nothing. 7 is significant, okay? So 7 moving across, okay, this direction, okay, I found that 7 is significant. There's my little arrow going across. 7 is significant. Because there's a decimal place, everything after it to the right is significant. Just done. Okay? So 7 is significant. And all of these zeros, the 6, and even these zeros are significant because there's a decimal. So once you've done Rule 1 and Rule 2, check for a decimal. If there's a decimal, you move across till you find your first significant figure, okay, which in this case it can't be a 0, right? Because a 0 would have to have 2 things on each side. So you're looking for your first 1, 2, 3, 4, 5, 6, 7, 8, 9. When you find it, since there's a decimal, everything to the right, all the way, keep going. Everything that you see listed would be significant. So in this case, it stops here because the number stops here. Okay? Let's go through and do Rule 1 and Rule 2 and Rule 3 for number 10 here. Okay, so 10, Rule 1, 1 is significant. Okay, 0 is not. Rule 2, see if there's anything between. Well, there's 1 on this side, nothing on this side. All right, Rule 3, is there a decimal? Nope, you're done. So you've got it. So the only thing that's significant is 1. Let's do 100. Rule 1, okay, so 1 is significant, just that. Okay, Rule 2, anything in between? Well, there's 1 over here, but nothing. Nothing, so just the 1 is significant. Is there a decimal place? No, you're done. It's just 1, so this is just one significant figure as well. Let's do 1,000. Rule 1, 1, 2, 3, 4, 5, 7, 8, 9. This is significant. Nope, nope, and nope. Nothing there. Okay, so we can only do 1 because these are all zeros. There's nothing over to the right side of the zeros that we can count. So then we do a check. Is there a decimal? Yes, there is. So moving across from the left to the right, moving across, boom, found 1. It's significant. There is a decimal. Everything is significant all the way across, all 4 of them. Everything's significant. Okay, now sometimes you see numbers like in an odometer. An odometer is, of course, measuring the mileage of the car. So if we have a car here that's got 4 million, I love how many miles that is, 4,060,890 miles that's on the odometer. Okay, same thing applies. We're going to look at Rule 1. So looking at Rule 1, we see significance here, significance here, significance here, significance here. Okay, so we've got those. Rule 2, anything in between? Well, nothing there, so that can't be. This one's got 2 things on both sides. This has got 2 things on both sides. and this does not. Is there a decimal? Nope. So you're done. This has got 1, 2, 3, 4, 5, 6 significant figures. Next odometer here, the fancy digital kind. Okay. Not all of them have this, but we'll move it on. Do our first check. So we've got significant, significant, significant. Then we check for anything on the left and the right. Can't do the first two. We can do that 0, but we can't do the other ones. Is there a decimal? Yes, there is. So pay attention to this one. Moving across from left to right. Is this significant? Is this significant? No. Right? There's nothing on left side. Is this significant? No. Is this significant? Yes, because it is. Everything else to the right is significant. Okay, so the last piece here that's pretty important is where we get to after this, which is how we do multiplication and division and addition and subtraction. Okay, first thing we do first is we're going to see significance. Okay, so first of all, looking at this number right here, 0.11, this is significant, the 0 is not. We would be done. We check for decimal. There is a decimal. So we start with the first one, 0 is not, 1 is, so everything after is. In this case, it still gives us 2 significant figures. Starting with 101, this is significant, this is significant. That's the end of the first one. 2, anything in between that? Yes, this 0 is. So this is there a decimal? There is not, so we just go with 3. In multiplication and division, you're looking for the smaller of these two numbers. So which of these numbers has the least amount of significant figures? The answer is this one right here, because 2 is much smaller than 3. So we move over, again, just like we did before, from the left to the right. So by doing that, we're going to do 1, 2. We stop at this place right here. Do we round up? Well, we look at the third digit. This is not 5 or higher. So we round down. So the answer to this question is going to be 11. Okay? We can then do addition and subtraction. Addition and subtraction, totally different than multiplication and division. Totally. Okay? Which is why, again, with rule 3, I like you thinking that way, because we're about to do that for addition and subtraction. First things first, let's count the significant digits. Okay, so we've got 255. Okay, so in this case, 255. That's the end of that one. Okay, for the next one, we've got 100. We've got 1, 0, 0. Okay, so we can't count those as their decimal. There is not, so that one's done. And then we've got 30.5, so 3, 5. Anything in between, we got a 0. There is a decimal, so you move across to the left, you hit the 3, go across. In this case, it still is all 3 of them. Okay, so we've got 3, we've got 1, we've got 3. In addition, subtraction, it has nothing to do with the number like it does with multiplication and division. It has to do with the place. So we're going to move across to the left. So for 255, let me go ahead and pull that up here so you can see it. For 255, we start this way. Is this significant? Yes, that's the 100s place. Is this significant? Yes, that's the 10s place. Is this significant? Yes, that's the 1s place. It stops there. So this one stopped at the 1s place. Let's do 100. Okay. I'm moving across this way. Is this significant? Yes, that's the 100s place. Is this significant? No. And this is not significant. So this one stops at the 100s place. For 30.5, okay, we've got this is significant. That's the 10s place. This is significant. It's the 1s place. This is significant. It's the 0.1s place, or the 10th place. Which one of these traveled the least? If we're moving across from left to the right, which of these traveled the least? Well, 255 traveled all the way to the 1s place. 100 only traveled to the 100s place. And 30.5 traveled all the way to the 10th place. So the one that traveled the least from the left to the right would be the 100s place. So our answer actually has to be limited to the 100s place. So we have 385.5. We have to stop at the 100s place. Do we round up or down? We round up. The answer is 400. Okay? Also, side note, don't put a decimal at the end. If you put a decimal at the end, it's no longer one significant figure, which it should be. We make it 3 by putting the decimal. Okay, so make sure you don't put decimal places unless you need them. Okay? If you have any questions, just let me know. I just thought this would be helpful for you guys as you go through significant figures. Again, if you have any other further questions, just reach out and we'll be happy to assist you. Take care. Have a great day.